Today I'm going to present the work that we do on the Satori team to power multiple being experiences through building our knowledge graph. And there's some trade-offs here, or at least some conflicting things where, to improve our freshness and coverage, it's harder to ensure correctness. And similarly, with better correctness, we might have to sacrifice some freshness or coverage. But it's really important for us to be correct. We don't want to show the user something that's wrong. Okay, so it starts out with raw data sources. This can be both structured and unstructured. So it could be websites like Wikipedia, IMDb, or other websites that have tables of information. It can also be unstructured. You can have paragraphs and have to do some natural language extraction. Once we take that, we then need to schematize it and correlate it with our existing data and relationships. And at the top of the pyramid, we get high quality, linked and schematized knowledge. And of course, we also get knowledge just through being a search engine, right? When people search for things, this tells us how popular those are. When they click on links, it tells us which ones are more popular than others. So we also learn about a lot through that. Of course, through our search engine, our web crawler, we get lots of web pages, images, and so forth. Yeah, this is kind of an ongoing effort, right? Our job is never really done. We're always expanding which sources we cover and how much knowledge we have. And these are the active areas we work on: data ingestion and extraction. Once we get those entities, linking them to the right one, doing inference on top of the graph, publishing and serving it. None of this is important if you can't help somebody in their search. On top of this, we continually improve our ontology, and we get feedback on the data quality. So we bring in entity name, if it's a movie, ratings, description, watch links, other related movies, TV listings for TV shows, job listings for companies. Anything you see in these panes is all coming through Satori, where we have to first get that data from somewhere, and then and these are coming from different sources, right? You see, we've got IMDb, TV.com. We have to make sure that the Big Bang Theory we see on one website is the same as the Big Bang Theory we see on another website, and not assign it to the wrong entity. So the richer the data that we can provide, the better the user experience will be. For politicians, this might mean, what bills have they sponsored recently? How can we make the UX really kind of shine on recipes, for instance? And if somebody's sending something that looks like we can just directly answer it, can we go to the graph and provide that answer for them directly? So this is even more complex query where somebody's asking, what is the most touchdown passes in the fourth quarter? You have to recognize that this is related to NFL, and we're looking for here a quarterback who is doing a bunch of touchdown passes, and specifically we're only caring about the fourth quarter of the game. So we power this by first populating the graph, of course, and then doing a graph query on that, converting the natural language query into a graph query that can give us these answers in a listed order. Similar, so directly answering questions here about the area of the country. Yeah, and further challenges that we face. There's lots and lots of different types of entities, right? And one source doesn't necessarily cover all of them, right? And on top of that, it's not just like there's lots of different websites, but each of these types of entities has their own properties, right? A spacecraft has, its engines and how fast it can go. Political leaders have, like we saw, bills that they've done, what positions they've held, real estate has square feet and area, price. Transit stations have their location and maybe when they were built and so forth, right? Each of these has their own properties. So it's very difficult to come up with a generic approach that covers all of these. Okay, so yeah, one kind of the simplest way of approaching this is web scrapers. It's kind of an older approach. You kind of look into the HTML and you look for a pattern. This element of the HTML with say this CSS class always has this particular field of information. So there's those types of rule-based approaches, regular expressions, wrapper programming languages, and so forth. I'll keep going. And like I said, these they can degrade over time as the websites evolve, as websites become more complex, more CSS and JavaScript. Once we extract the information, we've kind of talked about that to normalize. Two addresses could mean the same thing. So when we show this in the UX, we want it to be in a standardized format, but also when we match to existing knowledge, we want it to be in a normalized format. So yeah, this is just kind of an example. These three websites all have cast and director, but they say it in a slightly different way, right? Directed by, director, cast, starring. So we need to extract those and match them up. And we need to be able to match entities, even if they're coming from different subject areas. So Tom Cruise might have some websites covering his movies, another website might cover his music, yet another website might cover his marriage. So we need to know that all of these are the same Tom Cruise and match them up. And if you do this wrong, you're going to get a lot of complaints. So this was an issue here that happened where someone with a similar name got the wrong fields. Another example, all these are John Carter entities. So we need to be able to keep them separate when they should be separate and merge them when they should be merged. We match these up through the fields. So if on the left we have a website where we need to extract, on the right we have our existing graph. First we kind of turn the website extraction into a graph, and then we do some alignment or matching on the graph. So we need to know that this film is the same as that film. This actor is the same as that actor. And of course it helps when there's edges or these paths between the two, and the same thing matches on our side. And you match the various properties, right? 2006, 2006, and so on, to help you be more confident that this is a match. Yeah, and then we do some fact resolution. A zip code, we know kind of certain relationships between zip codes and cities. So if that is not correct, not holding on a given merged information, then it's probably wrong. Also, birthdays should be before death dates and so on. So these can help us detect various errors. Yeah, just another example of kind of how once we merge all this information from lots of websites, we can get a rich experience. It's another example, if you search Seahawks coach, we can not just show you a nice rich card, but show you the most relevant piece of the information you seem to be seeking. Yeah, so to do that type of thing, right? If you ask 2017 movies starring the actor that played Batman in Batman, we need to semantically parse that into something that's kind of aligns with our graph and be able to do a graph search. So that we need the knowledge to be there in our graph and be able to do this at query time. Similar example, top animated movies 2015. We got to have all that relevant information. We need to know the names of movies, that they are movies, the image to show you the years that they're released. We need to know the genre, and we need to just do some measure of popularity to indicate whether this is top or not. Then we semantically parse this query into a graph query. And of course, on the extraction side, that looks similar to what we saw before. And then finally, at serve time, we can give you a nice list where this relies, of course, we have to have a complete information. If you ask me for the top movies and I miss something that you thought was a really important movie, you're gonna have a bad experience. You're gonna look for some other source for your information. So how do we know when to serve a given entity's card for a query? Obviously, like if the name matches, that's one thing, but we can do we rely on more than just that. We also look, for instance, at the links on the page. We assign each page to an entity ahead of time. So in this page, actually, there's 3 different entities. There's a cartoon character, a TV show, and the animal. And because the animal seems to be more predominant here, then we know, okay, we can show the card for the animal and not the others. We've also recently added interesting stories on the entity panes. So in this case, we're trying to give you, a nice maybe profile article for the entity that gives you an overview. Some more examples. How many medals did Michael Phelps win in Rio? Have to identify that Rio means the 2016 Olympics. And there's a lot of challenges involved here. We have to do entity linking on the articles. We also have to know not just that the entity is present and mentioned, but that they are very salient to that article. And of course, we have to assess the quality and depth of the articles so that we can then show them directly on the entity pane. To summarize, there's a lot of information of varying quality available on thousands of websites out there. We need to be able to extract and clean on an ongoing basis. Quality is kind of number one, and to aggregate that and trigger it in the right context, we have to know that to do the entity matching, so the different entities on different websites all get merged together, and then at retrieval time, right, within hundreds of milliseconds, we need to do the query parsing, the graph search, the data retrieval, and render the UX very quickly. We definitely have some of that. There's also some deep learning going on there, so you can help know that 2 things are the same. A lot of the matching also relies on having enough information that all these fields match, right? If the name matches and the birth date matches and the spouse and name matches, that's starting to become enough, high enough probability that it's probably the same entity. You have so many different ways of knowledge being expressed on the web, and then there's so many different sources of it. We want to have everything, right? We want to be able to bring as much knowledge as we possibly can. So we're trying to kind of make things more generic, less hands-on, where using some of these newer techniques, you start to have more world knowledge, where the system can take over some of the manual tasks. We don't have to, for the 100th time on a new website, we don't have to say, oh, here's the name, here's the birth date. Like, can't you be smart enough to figure that out on your? So we're hoping to expand way more sources of knowledge.